Applications like domain-specific IoT, smart healthcare in connected world. So in this, the paradigm shift in healthcare, that is the main reason for this kind of new things in the world. Like old model, like episodic or reactive, sick care, like patients visit hospital only when they are sick, and limited data points, example, annual checkups, and high cost or late diagnosis, and patients' anxieties. These are all the challenges or demerits in the old system or old models. The new model has the continuous and proactive IoT driven, and which is has a healthcare system and continuous monitoring and prevention. That is one main advantage of the healthcare, and rich real-time data stream from connected devices and personalized predictive and participatory. The role of a CSE engineer to build the secure, scalable, and intelligent digital backbone that makes this new model possible. The IoT stack in healthcare, the IoT stack in healthcare. Let's map the generic IoT architecture to the critical domain of healthcare. Let's map the generic IoT architecture to the critical domain of healthcare. IoT layer, like perception or sensing layers. In this, like functions acquires physical or biological data. That is one functionality. And healthcare examples and technologies related to it, like sensors, ECG, EEM, EMG, EEG, and blood glucose, a pulse oximeter, accelerometer, GPS, cameras, devices like smartwatches, patches, smart pills, connected inhalers, and our relevance to our stream is embedded systems and sensors, fusion and signal processing for the computer science relevance, and network or connectivity layer. In this transmits data from sensor to the cloud. And what happens is short range, it is short range Bluetooth low energy BLE. Example to a phone, long range Wi-Fi, LTE or 5G, LoRaWAN, satellite for remote areas, networking protocols, QoS, power management, and HR fog computing layer pre-processes data near the source to reduce latency and bandwidth. Smartphone or local hub filters noise, detects critical events, example fall detection, triggers immediate alerts. Edge AI, real-time systems, data filtering, cloud data processing layer, stores, aggregates, and analyzes vast cloud platforms, AWS IoT, Azure IoT, Google Cloud IoT, or cloud computing database management. IoT layers like function and cloud and data processing. Like one more thing is like vast amount of data in functions and healthcare examples. You can also include data lakes, store structured and unstructured health data, and you have big data in the cloud elements. And the last one in the IoT layer is application or action. In this presents insight and triggers actions. Patient app shows a trends, medication, reminders, doctor's dashboard, like alerts, patient overview, automated systems, alerts to caregivers, control insulin pump, UI UX design, web domain, app APIs, and key application and scenarios and CSE perspective. This is the core of the our main lectures, and also the scenario one, remote patient monitoring, that is RPM, where the main problem here is managing chronic diseases like diabetes, hypertension, or heart disease outside the hospital. IoT solutions like devices, wearable ECG monitor, continuous glucose monitor, CGM, smart blood pressure cuff, and data flow sensor, smartphone via BLE, cloud, doctor's dashboard, CSA in computer science angle, like we say, like system must ensure data integrity. Under one is a corrupted glucose reading could be fatal, and reliable connectivity is non-negotiable. And we can take this scenario too in this elderly care and ambient assisted living (AAL). The problem here is like enabling seniors to live independently and safely. IoT solutions like devices, wearable fall detector, motion sensors, smart floor mats, pill dispensers with sensors, data flows, sensors, hub, cloud, alert to family or caregiver. A computer science angle is like this involves activity recognition algorithms, AAML on sensor data, and raises major privacy concerns. Monitoring daily activities and is intrusive if not handled ethically. We can take this scenario three, which is smart hospitals and asset management, where problem inefficient uh, use of resources, tracking equipment and patients inside the hospital. This is a big problem in smart hospitals and asset management. So IoT solution for this is like devices RFID tags on equipment, ventilators or wheelchairs, staff patient BLE badges, smart beds, and data flows like tags or beacons, local network or central hospital management system. So this is how the data flows from beacon to local network, central hospitals to management systems. And from computer science angle, like this is a classic interpretation in systems. IPS problem, it requires robust real-time location systems or TLS and integration with hospital software ERP. Scenario 4, medication adherence or problem patients not taking medication correctly. IoT solution devices, smart pill bottles with sensors, smart blisters, data flow bottle sensors of opening, sense time or data to app log those and sends reminder if missed. So, from computer science angle, like a focus on human-computer interaction and CI, the system must be simple and non-intrusive for the user, especially the elderly. The power of data, AAML in IoT healthcare, emphasize the data without intelligence is just noise. Uh, so, predictive analytics, analyzing historical vitals to predict a potential heart attack or hypoglycemic event. Anomaly detection flag unusual patterns in ECG data that might indicate arrhythmia. And personalized insights ML models can learn an individual's baseline and provide tailored healthcare recommendations. And computer vision perspective analyze medical images, X-rays, MRIs for faster and more accurate diagnosis. Example, an RPM system doesn't just show a doctor 10,000 ECG data points. It uses an ML model to highlight the 10 anomalous beats that need attention. Critical challenges and ethical considerations, SCCQRT. Security like threat, a hacked insulin pump or pacemaker is a weapon. Solution hardware based secure boot and end to end encryption, regular security patches, data privacy and ownership. In this threat, highly sensitive health data being leaked or sold. Solution strong data anonymization and compliance with regulations like HIPAA, Health Insurance Probability and Accountability Act, and GDPR, who owns the data, patient, doctor, or company. Reliability and accuracy threat. A false negative, missing a critical event, or a false positive causing panic can have a severe consequences. Solution for this is like redundant systems, high fidelity sensors, and rigorous validation of algorithms. Interoperability threat. Devices from different manufacturers cannot communicate, creating data silos. Solution advocacy for an implementation of standard protocols, example FHI or FAST, healthcare, interoperability resources. So this is some thing for additional learning like in-class activity using health IoT solution. So we can form among 4 to 5 groups in the class. Each group is a health tech startup. Scenario your task with the designing an IoT solution for managing post-operative recovery at home for cardiac surgery patients. The goal is to reduce readmission rates. Deliverables: a 5-minute pitch, product name and goal, list of 3 key sensors, devices, and what they measure, Data pipeline briefly describe the journey of data from patient to doctor. One key AI/ML feature your product will use, the biggest security privacy challenge you anticipate and how you will address it. Conclusion and key takeaways: IoT is revolutionizing healthcare by making it data driven, preventive, and personalized. The role of a CSE engineer is critical and multifaceted, from embedded systems and networking to cloud, AI, and most importantly, security and ethics. The future lies in closed loop systems, example, and AI analyzes glucose data and automatically adjusts an insulin pump and integration with genomics. This field offers immense opportunity to build technology that has a direct positive impact on human life. Further readings are we could do a case studies of Philips EICU and Proteus and Discover smart pills, continuous glucose monitors, Dexcom freestyle liver, and standards HL7 FHIR for healthcare data interoperability. Regulations HIPAA US, GDPR EU, and important for any developer in this space. You can watch video like The Future of Healthcare, IoT by IBM or Intel available on YouTube. Thanks for watching. Have a nice day. Bye.